Happy day everyone. This is Shweta from Department of Mathematics. Today we are going to learn set language. First of all, what is set? A proper definition of set is a set is a well-defined collection of objects. A set is nothing but a group of things that are clearly listed or described. A well-defined means there is no confusion. We can say yes or no easily whether something is belong to the particular group. For example, the collection of all colors in a rainbow, the collection of prime numbers. In the right hand side, we will see the pictures. Apples, fruits and bananas, these are belong to a particular set. These apple, grapes, banana or belong to the set A means these fruits are called elements of the set A. That is, things which are listed in the particular set are called as elements of the particular set. Next, representation of a set. We can represent a set into three different types. First, descriptive form. In descriptive form, a set is described in words. For example, the set of all vowels in English alphabets, the set of whole numbers. Next is set builder form or rule form. In set builder form, all the elements are described by a rule. For example, x a equal to, if a is a set, we have to write a equal to x such that x is a vowel in English alphabets. Next example is b equal to x such that x is a whole number. We have to read that slash and double dot is such that, it means such that. Next, roster form or tabular form. A set can be described by listing all the elements of the set. We see, I explained in the previous slide that what is element of a set. The things or objects mentioned in the particular set is called elements of the set. So here in English vowels in English alphabets, we have A, E, I, O, U. So these are the elements of the particular set. So here we have to write like this: A, comma, E, comma, I, comma, O, comma, U. This is the format of writing the roster form. Next, we'll move to types of sets. First, empty set or null set. A set consisting of no elements is called the empty set. Null set or empty set is denoted by open flag bracket and close flag bracket, and otherwise we'll denote as null set. We have the symbol like we'll put 0 and straight line between the 0, but here it is given wrongly, that they mentioned as q. Just avoid it. Next, we will see singleton set. A set which has only one element is called a singleton set. For example, the set of all even prime numbers. We know that 2 is the only even prime number. That is, the set consists of only a single element, that is 2. So it is a singleton set. Finite set. A set is finite. A set with finite number of elements is called a finite set. A finite is nothing but which is countable. The set of family numbers. We know, obviously, we know our family members. So it is countable. So it is a finite set. Infinite set. A set which is not finite is called an infinite set. That is, which is not countable. For example, 5, 10, 15, etc. These are the multiples of 5. There is no n. So it is an infinite set, so that we cannot count it. Next, I have a question for you. The set of all whole numbers is a finite or infinite set? We have to answer for this. Next, cardinal number of a set. A number of elements in a set is called the cardinal number of elements. Cardinal number of the set. The cardinal number of a set A is denoted by small n of A. A is the set mentioned here. If they given you the set B means you have to put B in the place of A. The number of elements in the set is called cardinal number of elements. That is, if in the set A we have 1, 2, 3, 4, 5 means we have 5 elements in the set. So n of A equal to 5. Next, equivalent sets. Two finite sets A and B are said to be equivalent if they contain the same number of elements. It is written as A equivalent to B. For example, consider the set A. In that set, we have two elements, ball and bat. That is n of A equal to 2. And in set B, we have history and geography. The number of elements in set B is 2. So here n of A equal to n of B. That is mentioned below, mentioned above. If A and B are two equivalent sets, then n of A equal to n of B. That is n of A. For the given example, we get the answer n of A equal to 2 and n of B is also 2. So the number of elements in the given two sets are equal. So that is called equivalent set. Okay. Next, equal set. Two sets are said to be equal if they contain exactly the same element. Otherwise, they are said to be unequal. In other words, two sets A and B are said to be equal if every element of A is an element of B, every element of B is an element of A. For example, here the set A consists of 1, 2, 3, 4, 4 and n of A is 4. Here the B consists of 4, 2, 3, 1, that is n of B equal to also 4. But this is not a matter. Here A consists of the element 1. B also have that one element 1. Here A consists the element 2 and B also have the same element 2. Similarly 3 and 4. The set A and B have the same elements, exactly the same elements. Here no matter about the number of elements, but exactly the same elements they have to contain. So here A and B are equal sets. Don't get confused. Equivalent is different from equal set. In equivalent set, number of elements of A is equal to number of elements of B. But in equal sets, the set A and B should contain the same elements. If it is here A equal to bat, ball means B is also contain the element bat and ball only. But the order may be changed, no problem. Here also 4 comes first and 2, 3, 1 in the B set. But that's not a matter, but they both contain the same, exactly same elements. So it is called equal sets. Otherwise it is unequal. Next, universal set. A universal set is a set which contains all the elements of all the sets under consideration, and it is usually denoted by capital U. We denote the universal set as capital U. For example, if A equal to Earth, Mars, Jupiter means, then U is the planets of solar system. So U is the total planet of solar system, but A is the part of it, that is Earth, Mars and Jupiter. Next, subset. Let A and B be two sets. If every element of A is also an element of B, then A is called a subset of B. That is, if A have the element of 1 to 5, then we have the element of B like 1 to 10 means the set B contains the numbers from 1 to 10. But the set have the numbers 1, 2, 3, 4 and 5. But every element of A, 1, 2, 3, 4, 5 is also an element of the set B. Because 1 to 5 contains 1, 2, 3, 4, 5. Na? 5 means, so the elements of A is also an element of B. But they should know that there is not equal or anything. But the element A fully contains the element A is also an element of B. That then A is called a subset of B, but B is not a subset of A. You can clearly understand. Only A is called the subset of B. Next, disjoint set. Two sets A and B are said to be disjoint. Disjoint means obviously they are not together, they are separated if they do not have common elements. So the set A and set B are separated, that is they don't have any common elements, then we call it as disjoint set. In otherwise, if A intersection B equal to null set, this is a symbol of null set. we'll see in the empty set, no, they mentioned wrongly. So this is the correct denotation. This is how we denote null set or void set or empty set. And A and B are said to be disjoint set. Disjoint means the name itself we can understand. Now A and B, two sets A and B are not joined together or not together. So there is no intersection. That is, intersection means there is no common elements. We have to read, in other words, if A is the symbol N, like we ulta, we have that we called as intersection. In this, we don't have A intersection B. That is, null set means we don't have elements of intersection, common elements. So we should not get elements that is common in B, or A should not contain the elements of B and B should not contain the elements of A. So that is, they are disjoint set. Next, power set. The set of all subsets of A is called a power set of A. It is denoted by P of A. Power set is nothing but set of all subsets of A. Is called a power set of A. It is denoted by P of A. For example, A equal to 2, 3 na. Then find the power set of A means the subsets of A. How we have to find the power set of A means we have to find the first subsets of A. What is the subsets of A? What are all the elements inside the inside the set A? That we have the element 2 and we have the element 3, and we will write it as combination of 2 and 3, and also every subsets of something will contain the null set definitely. So we have the definite set also, null set also. The power set of A is P of A equal to open curly bracket, open flower bracket, null set 2, 3, 2 and 3, and the close flower bracket. Next, how we calculate power set? How we have to calculate the power set? We have the formula by using an important property. If n of A equal to m, that is the number of elements in the set A, we take it as m, then n of P of A equal to 2 into m. No, that is 2 power m, 2 power m. The number of proper subset of a set A is n of P of A minus 1 equal to 2 power m minus 1. That is 2 power m, okay? Not 2 into m. That is 2 power m. Wait, I'll show you. Kindly note down this. That is not 2m. It's wrong. That is 2 power m. Okay. And in the next class also, the number of proper subset of a set A is n into P of A minus 1 equal to 2 power m minus 1 is the formula, not 2 into m. Kindly note it down. Next, we are going to see about set operations. First, we are going to see complement of a set. The complement of a set A is a set of all elements of U. What is U? Universal set. The complement of a set A is the set of all elements in U, the universal set, that are not in A, but it should not be in A. That is, a complement of a set is set A is the set of all elements in U, but that are not in A. So we have to remove the elements of A and we have to write the remaining elements of U. Because U consists of all the elements, in that we have to remove the elements of A and we have to write. That is the complement of A. We also denoted as A complement. We have to put A, and in the power we have to put a slight dash, or A power C also we can write. Here We have the Venn diagram in the right side. First one is we have shaded the A region. Okay, we have the set A and we have to shade the A region. In the second case, we have to shade it for the A complement. So they just removed in the shaded region only will take into account. So they removed the shade in the A region and they shaded overall the universal set region. So it is Venn diagram for A complement. If example U equal to all boys in a class, A equal to boys who play cricket. U is the universal, all boys in a class. A is the whole class who plays the cricket. Okay. Then complement of set A is how we find. A dash is we have to minus or omit the set A from the universal set. That is obviously boys who do not play cricket. That is A dash. Because A is the set of boys who plays cricket. We have to remove them from the universal set. That is the whole boys. So they in that whole boys, they are the boys who are playing cricket and who does not. So we have to remove the boys who play cricket. So remaining of the set U all, they do not play cricket. So that is A complement. Okay. Sorry. Union of two sets. The union of two sets A and B is the set of all elements which are either in A or in B or in both. Union means we have to combine all the elements of the set together. That is the simplest way we have to say union. It is denoted by A, that U symbol, and B, but we read it as A union B. Okay. For example, if the element P contains Asia, Africa, Antarctica, Australia, the 4 elements, Q contains Europe, North America, South America, then the union set of P and Q is, that is P union Q is, we have to combine all the elements of P and Q and we'll give it as P union Q. That is Asia, Africa, Antarctica, Australia, Europe, North America, South America. Here we have the Venn diagram for the A union B. That is, here the pink color shaded region is the A union B. That is A set and B set, and also the whole the intersection also takes place because we will write as together. So it may be it contains the elements of both the set. So we have to shade A union B like this only. Okay, the pink color shaded region is A union B. Behind that A union B is universal set. Okay. Next, intersection of two sets. The intersection of two sets A and B is the set of all elements common to both. Intersection is nothing but the elements common from these two sets A and B. It is denoted by A intersection, that is the ulta form of U, that we read as A intersection B. For example, A equal to 1, 2, 6 now, B equal to 2, 3, 4. Here the intersection, what is the common element in A and B? Here 2 is the common element. So A intersection B is 2. The common part of A intersection B, which is means the in the Venn diagram you can clearly see that A is the set and B is another set. It contains the universal set contains these both sets, and the common is shaded there. That is A intersection B. The shaded region is the A intersection B. Now we are going to see about difference of two sets. Let A and B be two sets. The differences of set A and B is the set of all elements which are in A but not in B. It is denoted by A minus B or A slash B and read as A difference B. We have to read that slash here as A difference B. For example, if we have the set of elements in A and set of elements in B, we have to find A minus B means we have to cancel the common elements in A and B, and we have to write the remaining elements in A, but we should not include the elements in B. You can see the Venn diagram here. Here we first done for A minus B Venn diagram. In this, the common elements of A and B were cancelled, that is not included, and the elements of B also not included. Only the part A without the common element, that is the intersection, we have shaded, that is for A minus B. Similarly for B minus A. Now, symmetric differences of sets. The symmetric differences of two sets A and B is the set A minus B union B minus A. It is denoted by A symmetric B. We have to read that asymmetric B. Here we have the formula for asymmetric B equal to A minus B union B minus A. That's a formula for symmetric of sets. Difference of sets. That is what here shown in the Venn diagram. Okay. Next we are moving to properties of set operations. First one is commutative property, which is nothing but for any two sets A and B. First, for every property we have two types, for union and for intersection. First one is union. Commutative property for two sets for union is A union B equal to B union A. And then for intersection, A intersection B equal to B intersection A. For these types we have to prove for RLHS and also for RHS. Associative property. For any three sets, here we will take three sets A, B and C. This is the property for union. A union open bracket B union C equal to A union B bracket union C. Second, A intersection B intersection C equal to A intersection B intersection C. Then we have distributive property. For any three sets A, B and C, intersection over union, that is A intersection over union. So B union C equal to A intersection B union A intersection C. Next is for union over intersection. So A union B intersection C equal to A union B and A union C. De Morgan's law for set difference. We have the De Morgan's law, that is for any three sets A, B, C, A minus B bracket open B union C equal to A minus B intersection A minus C. And for intersection, A minus B intersection C equal to A minus B union A minus C. The union and intersection will interchange. Okay. Now De Morgan's law for complementation. Let U be the universal set containing finite sets in A and B. What do you mean by finite? Do you remember? Finite set means that is countable. So De Morgan's law for complementation contains U be the universal set containing finite sets A and B. The property is A union B the whole dash equal to A dash intersection B dash. You can say otherwise A union B the whole complement equal to A complement intersection B complement, and A intersection B the whole complement equal to A complement union B complement. Okay students, we will end the video with few questions. You will practice these questions at your own pace. We will see the questions one by one. Which of the following are sets? Collection of natural numbers, collection of English alphabets, collection of beautiful flowers in a garden. We know what is set. Set is a well-defined collection of objects. Second question, is the set of natural numbers a finite set? You know what is the finite means, which means countable. Write in roster form. Roster form as a format, you have to write each elements without repetition, okay, in the given question. Write any two properties of set operations. We'll see we'll see three operations, that is commutative, associative and distributive. You can write any two. If A equal to they given some elements and B equal to some elements, then find A union B. A union B means we have to club the elements of A and B and write it together. Okay students, I hope this video helped you to understand the concept of set language. Thank you.